Chapter 3. Summarizing Data, Measures of Location. The median represents the typical value in a set of data. It is the middle entry, or the mean of the two middle entries in a set of data when the values are arranged in an increasing order. The median position in a set of n values arranged in an increasing order is the number n plus 1 divided by 2. For example, if n equals 55, then the median position is 55 plus 1 divided by 2, or 56 divided by 2, which is equal to 28. If n equals 34, then the position of the median is 34 plus 1 divided by 2, or 35 divided by 2, which is equal to 17.5. The median divides a set into two halves. All the values in one half are lower than or equal to the median, and all values in the other half are larger than or equal to the median. The mode is the value that occurs most frequently in the dataset. It is possible that the mode does not exist for a particular dataset. The data has a unimodal distribution if a unique mode exists. If two modes exist, then the set has a bimodal distribution. In this example, the number of people served at a restaurant in 15 days are given. To find the median, we arrange the data in an increasing order. The median position is 15 plus 1 divided by 2, which is equal to 8. So 50 is the median number of the people. The mode is the value that occurs with the greatest frequency. In this example, there are two modes, 38 and 54. We say that the data has a bimodal distribution. The nth percentile of a set of numbers is a value such that n% of the numbers fall below it and the rest fall above it. We can regard quartiles as special percentiles. The quartiles intended to divide a set of numbers into 4 equal parts. The second quartile, q sub 2, is the same as the median of the dataset. To find the first quartile, q sub 1, compute the median of all values falling below the position of the overall median. To find the third quartile, q sub 3, compute the median of all values falling above the position of the overall median. The smallest value in a set of data, the first quartile, the median, the third quartile, and the largest value, give us 5 numbers that can be used to summarize a set of data. These 5 numbers can be used to draw a box plot. The median is marked by a vertical line in the rectangle, and the first and third quartiles are marked by the left edge and right edge of the rectangle. The lines extending from the edges of the rectangle to the smallest value and largest values are the whiskers. In the following example, we are given the thickness of grease coating in microns produced on 20 steel rods. To find the median, we need first to arrange the data in an increasing order of magnitude. The median position is 20 plus 1 divided by 2, or 10.5. This median is obtained by finding the mean of the two middle entries. Thus, the median is 55 plus 57 divided by 2, or 56 microns. The first quartile position is 10 plus 1 divided by 2, or 5.5, in the lower half of the dataset. Therefore, the value of the first quartile, q sub 1, is 46 plus 48 divided by 2, which is equal to 47 microns. The third quartile position is 10 plus 1 divided by 2, or 5.5, in the upper half of the dataset. The value of the third quartile, q sub 3, is 61 plus 63 divided by 2, which is equal to 61 microns. Now we can observe that there are 5 values less than q1, 5 values between q sub 1 and the median, 5 values between the median and q sub 3, and 5 values greater than q sub 3. The following table illustrates the typical way in which data is grouped in a frequency table. There are k classes with class marks x sub 1, x sub 2, up to x sub k, and the corresponding frequencies are f sub 1, f sub 2, up to f sub k. The sum of all the measurements can be approximated by multiplying each class mark with a corresponding frequency and adding up all the k results. The mean of the distribution is given by dividing the sum of all the measurements by n, where n is the sample size, which is equal to the sum of the frequencies. In this table, the distribution of the percentages of students who are bilingual in elementary schools is given. We start by finding the class marks for the 5 classes. We use the formula in the previous slide to find out the mean, which is given by dividing the sum of all measurements, 390, by 50, which gives us 7.8%.